almost good to start. Rick, you want to pitch in? Thank you, everyone. So again, I just quickly introduce myself and then I'll hand over to Rick to introduce ourselves. I'm Dheeraj Singh and I'm the CEO and co-founder with United States America. I am basically an expert towards the data and data warehouse, BI, and the cloud side of it. And I will let Rick talk more about our company and us. Thanks. Rick, want to start?
Yeah, hi. Hello, everyone, in whatever time zone you're in, and thank you, Dheeraj. We have some slides here that will introduce ourselves and our services. As you know, as many of you may know, that the fourth industrial revolution is actually the current and developing environment in which we use technologies and trends such as the Internet of Things, robotics, VR, artificial intelligence, etc. Well, the fifth IR, industrial revolution, is where we're pitching at, which is what our company is focused around. I'll more about that a little bit later on. But as you can see from the current slide, we are actually focusing around creating experiences such as self-services, demos, and a self-service trial, which give prospects a taste of the service experience. The key message here is that products are evaluated and services are experienced. Let me just forward to the next slide. So just a little bit about multi-cloud for you. What do we do? What do we stand for, etc.? Well, we are a company that's offering products and services based around a whole plethora of technologies. Evangelism in the community is essentially at the heart of everything that we do. The key technological areas that we focus on are multi-cloud strategy, data science, artificial intelligence, blockchain, extreme engineering. We effectively act as the bridge between corporate and startups, and this is our focus. So we wish to guide the engineering community. We are all technologists alike that have a lot of shared interests. In addition, we provide technological areas that we focus on our multi-cloud strategy, product and research, as well as being on board with solution architects, data architects, and our focus overall is multi-cloud and data. Let me just tell you a little bit about this platform here, which is we're all engaged in. It's the fifth industrial, fifthir.com. Low on lights and camera, but the emphasis is that we're high on value-driven engineering. It's focused around value-driven. That is one of our key mottos here. So Fifth IR is effectively a software as a service, and it's based on a self-service platform. It connects technologists from startups and corporate alike. And we have a transitional support onto Fifth IR. Our motto is to make the engineering community ready for the transitional transformations induced due to the shift generated by the upcoming Fifth IR, the fifth industrial revolution. Whilst we all embody all the various new technologies, etc., this is our offering in terms of being able to bring technologists together to understand the various different types of technology and to share like-minded experiences. We are essentially out to right across the world. Their impact is being felt right across the world. We are gathering people, technologists from all over the globe. Although we initially created centrally in India, the impact is now stretching far wider than that. Today's seminar will be hosted by Suresh Kandula, the Build SaaS platform with confidence. Learn the multi-tenant architecture that sits behind SaaS. And thank you all for joining. I hope you can hear me well. Suresh actually is the vice president at Sapient and has a vast amount of experience in architecture and delivering enterprise scale SaaS platforms. And he's based around in New York at the moment, US. I'm a co-founder of multi-cloud for you, a CEO in the UK. My background is on building data warehouse systems. I'm somewhat of an expert in using business intelligence systems, and I've been based around, for a large part of my career, around investment banks here in the UK. But essentially at the heart of, in terms of technology, it's based around data warehouse and the associated reporting and business intelligence that comes around it. So without further ado, I will now hand over to Suresh, who will take over from here. Suresh?
Thanks, Rick. Let me share my screen first. Yeah.
Okay.
When you can see the screen.
We do.
Awesome.
Thank you, sir.
Okay.
That's good.
Thanks everyone for joining, and excited to share, my thoughts on SaaS platforms with your community, and get started. In terms of agenda for today, as Rick mentioned, we're going to talk about what is SaaS and why SaaS. And what are some of the key principles, and what are some of the architecture patterns that you should consider when building platforms that are part of software as a service platforms. So before we kind of go into some of the details, what is SaaS? So there's a bit of a definition that I use, and I want to expand on that so that it's clear to understand what is SaaS, what is not SaaS, because there is a lot of confusion around what is considered SaaS platforms versus a traditional web application, consumer-oriented platforms, why SaaS is different, and why you should consider SaaS patterns when you're building your application. So there are 4 key, constraints or, methodologies that you have to look at before you call something SaaS. One is it needs to be a fully managed service, and I'll go through some examples of that, meaning a customer of yours, whether it's an individual customer or corporate-centric customer, they don't have to worry about managing that particular process or component or module. So it needs to be a fully managed. It needs to solve a customer or corporate-centric problem, business problem. So if you're building a retail website, you may want to call it SaaS, but it's not. It's not really solving a business problem that needs to cater to different types of customers or corporate-centric customers. So it needs to be fully managed. It needs to be a business problem solution, and it needs to support self-service, because you cannot scale a software. Now, you might actually, 20 years ago, you might have delivered your software over a CD, bundled and send it over mail, but now it's delivered over cloud, it's delivered over APIs, so it has to be self-service. You cannot have people sit and onboard a customer. So these are the 4 key characteristics before you call something a SaaS platform. And there are various gradations of that. We'll go through that. I have a quick mental quiz for you guys before we go into discussing the patterns. So I have 9 different platforms that you might know of or you might have heard of, and some of them are SaaS platforms, some of them are not. Now I'll take one easy example, which is hotels.com. You might say, is it a SaaS platform? So for all of our consumers of hotels.com, you're booking a hotel, it may not be a SaaS platform, because it's not really doing anything different for different types of customers who are logging into hotels.com. But hotels.com might think that they have a SaaS platform, because they're actually solving a business problem behind the scenes of thousands of hotel chains to be able to onboard it into hotels.com. So, you might think on the face of it, something is not a SaaS platform, and from your point of view. But if you look at from a business point of view, there are some solutions that are SaaS platforms, some of them are not. In the case of hotels, you might say okay, it's not a SaaS platform, it's not a multi-tenancy required. You just have to pay for your hotel, book your hotel, and then move on. But hotels.com might not think that. Versus RDS, which is like an AWS relational data store, is it a SaaS platform or not? Some people will say it's a PaaS, because it's a platform that is actually being used by multiple customers or corporates. So there's a lot of gray area in terms of when you define something as SaaS or not. So I might have a view on it, like if you see here, I might say Hotels.com is not a SaaS platform, RDS is not a SaaS platform. I would say Shopify, MailChimp are SaaS platforms because anybody can go to Shopify and set up their own shop with commerce and marketing and integrated payments and all that. So it's really a point of view in terms of what it is from a software architecture standpoint. I'll talk about some of the characteristics and principles, and if you bump into them and if you see them, then you have to support some SaaS platforms. But don't judge from the face of it what is Hotels.com, whether Hotels.com is a SaaS platform or not. They might consider themselves as one. There are some that are easy to depict, like DocuSign, identity as a service. QuickBooks, or Zoho Books. Like in India, you actually have your own bookkeeping platforms are considered SaaS platforms because they support wide variety of customers. So what makes something SaaS? Like we looked at some examples, and there is a debate on what is considered SaaS depending on what side of the coin you are looking at. And there are a few key characteristics that determine something is a SaaS platform, and then you have to make sure that you follow some standard best practices around building a SaaS platform. So the first one is in a web platform, traditional web platform, you have to scale your application, meaning you could have 50 customers today, 500,000 customers, in a year from now, or 5 million customers, 5 years from now. But you need to be able to scale your platform. And in SaaS, you have to scale, but you have to scale in a very intelligent way. Like you might have a customer that have 5,000 accounts with you, or you might have a customer that has 5 accounts with you, or you might have a customer on Shopify that sells 8 million products, or you might have a customer that sells 50 products. And you have to compartmentalize them because you have to provide a different level of quality of service level agreements. So you have to scale compartmentally instead of scaling horizontally. So that's when one of the characteristics of the SaaS platform. You might have in a web platform, uniform demands, like anybody who's logging in to book a hotel room has a similar demand, like they're looking for the best hotel, best price, and then book it. Versus in a SaaS platform, you have uneven type of demands, depending on the type of customer, large customer, small customer. You have you're solving a business problem at the end of the day. If it's a SaaS platform, you could debate whether it's a consumer platform company is a SaaS platform, but we would rather save that time and effort for some other productive work. But generally speaking, it has to solve a business problem, a corporate problem, not a consumer problem. You have to support tiering of services because someone wants to pay only for minimum set of features. Someone wants to pay extra features. Someone wants full service, white glove service. So you have to have a tiering of services. And then you might have in SaaS platform complex regulatory requirements like Zoho Books, Shopify, depending on the country they operate in. They have to do a lot of regulatory support in terms of anti-money laundering. You have to do regulatory reporting, whatever the case is. So it is complex relative to a web platform that is, have a consumer-oriented regulations. So those are the key characteristics. If you see any of them, like 3 or 4 popping up into your platform requirements, you have to look at SaaS as, and then see some of the best practices and patterns for it. And, another topic before we go into some details, since we are going to spend only less than 30, 40 minutes, I didn't want to go through a lot of the details, but I wanted to take away at least 5 things. And one of the things other than defining a SaaS platform is what is multi-tenancy. So SaaS, software as a service, and multi-tenancy are kind of different topics, but they're closely related in building software as a service. Meaning if you're building software as a service, you have to cater to multiple types of customers. If you have Office 365, you might have someone who is using it for their own home use purposes, and then you could have someone else using it for 100,000 employee organization. So that's the reason why multi-tenancy is important. You could build a SaaS platform with a single tenancy. We'll go through that as part of our kind of maturity model, but the economies of scale will only be achieved if you are thinking about multi-tenancy in your SaaS software. Otherwise, you could always build, burn a CD and give it to 1,000 people, and it is supporting multiple types of customers, but it's not in a scalable economies of scale fashion. So that's why multi-tenancy is a orthogonal concept, but it's really equally important in SaaS. So what is multi-tenancy? So you have different types of customers. Like, for example, we take Shopify or QuickBooks. You have someone who needs a lot of support, like, large number of accounts, requires like reports to be built that will take up a lot of your compute needs that you might have, already provisioned on your cloud or in your on-premise. So in a horizontally compartmentalized scale platform, you cannot make any assumptions in terms of types of customers coming in, the amount of data that they're going to store, amount of compute that it needs. So you have to scale compartmentally because you cannot have one organization impede other organizations' performance in the application. So that's why it's challenging. And that's why we'll talk about concepts like isolation, multi-tenancy, that may not be applicable for a consumer-oriented, still scalable platform. So you have a lot of features that are driven by type of tenant that you have, which is a customer. And the customer doesn't mean single user. The customer could mean 50 users, 100 users, 200,000 users that are using, like say DocuSign. You might have a single person using DocuSign, electronic signature. You might have someone using, 200,000 employees sending documents to be signed to millions of customers, their customers. So it's really, a scalability at a tenant level. And then you need to be able to support registration of that, billing for them. You might have different models for pricing and billing. So supporting all of that in a multi-tenant environment is what's challenging in SaaS versus building a horizontally scalable platform for consumer. Okay, so we touched on some of these, but these are the 10 things you have to keep in mind if and when you're building a SaaS platform, or if you have already built software, that you have to make it multi-tenant. So one is you have to make sure that you have to support subscription models, like people come and go. Hopefully more people will come than people leaving, but you need to be able to support pay-as-you-go model. That means you have to integrate, billing models into your platform, like, in terms of features that are being used, enabling features, turning on and off, like someone wants to feature tomorrow, they don't want the feature like a month from now. So pay-as-you-go subscription model, feature-based pricing, like, making that like enterprise version versus light version versus economy version available to different type of customers. Obviously, like, since it's on the cloud and also it's available anywhere, like you have to make sure that you're always up and running. You have to be global and also local at the same time. In terms of supporting multiple countries, like their time zones, and also like supporting their format standards, like, simple things like date formats, like will make this a pretty complicated product on the back end. Simple concept like when is the day ending? When is the day not ending? What timestamps you are going to store? What is the audit? So a lot of things that are at a global and local level are going to complicate a SaaS platform. And it needs to be pluggable into client ecosystems. People are going to use this platform not just by logging into a screen, but they are going to integrate with APIs, integrate with their business process management tools. So it has to be an open platform. In terms of scalable, so you need to support, like, just because you have a large customer running a large job, you cannot stop a small customer doing a small thing. That is going to, not only from an experience standpoint, that is also going to be an issue for you to like grow in the longer term. And I'll stress on the fact that it is de facto cloud hosted. Because it's, it might sound obvious, but, large enterprises have been building SaaS platforms for decades. Like, large banks, large corporate platforms, they build software that supports hundreds and thousands of their corporate customers and clients. So it's not new. What's new is to be able to have someone who doesn't have a high barrier of entry to build platforms that are something similar. So, banks have been building SaaS platforms, large retail companies have been building SaaS platforms, B2B, logistics and supply chain companies building SaaS platforms, and all over last 20, 30 years, they use SAP, ERP, whatever the platforms they use, they have been building it. What's really different is they have the, capacity and the budget and the, wherewithal to actually build something, even if no one is coming, versus you may or may not have that as you are building a startup or you're building a small company. you could do SaaS, and the only way you could do SaaS is on cloud because of all of the other principles that are above that. And other thing is no ops. Like you cannot have, if you have 1,000 customers and each of them have different types of feature needs, you won't be able to deploy these things manually. You have to have, kind of advanced DevOps, and you could have maturity level. You don't have to have this on day one, but you need to be able to support what I call no ops. And it has to be very light touch. It has to go from developer to release with very light touching, including, onboarding, releases, billing, metering, the whole end to end. Otherwise, you can't scale. You can't take calls. You cannot load data manually. Like all that stuff won't scale. I mean, you could do that in the initial stages, but over time, you have to think about it. Regulations, we talked about that, and isolation, we talked about that. You cannot have a lot of large enterprises who have been building SaaS platforms. They have like deployments all over the world, like North America, in Singapore, in Latin America, in Europe, multiple places in Europe. Same software running in different places. They could afford that, and you should be able to afford now with cloud if you have the right customer base. But you still need to be able to isolate one customer or set of customers from other set of customers. If you have a problem in one of your feature release, you don't want every single customer to be impacted. So isolation at varying level depending on the complexity of your software. So those are the key principles that I would say you have to keep in mind, and you don't have to solve all of these on day one, but you need to have it on your radar. And there are 3 categories of SaaS architecture patterns, and I will go through some of them today, just given in the interest of time. But I also have in my deck, some reference material that you could take a look offline in terms of how to identify patterns, how to build patterns that are fit for purpose for your organization, and you don't have to do all of these on day one. So there are some data architecture patterns. Like a lot of the focus has been in the industry about data architecture patterns. But more recently, there are application architecture patterns that are coming up, deployment architecture patterns that are coming up, like multi-tenant containers, tenant isolated application architecture deployment. So there are new things that are coming up, but the core focus had been on data architecture patterns. So it's like what I tell some people on the data side. It's like sometimes it's as simple as adding a where clause. That's really what it takes to build a SaaS platform. But I'm just joking. But the more complex your application is, the more things you have to do on the data architecture patterns. Some of the key examples that you would find is, let's say you have one customer, you built a software, and they're using it. Now you have like 3 other customers. What are you going to do? Immediate thing that will come to your mind is, okay, let me just add a customer key, add a customer table, and then each data is aggregated by customer key, and then they'll get whatever the data they get, and then they will only see their data. So that should work, and when you're starting. But when you scale, you have this is vertically scaled database. Now you have 10,000 customers, and all of them want to use the same database. Then you cannot do the customer key thing anymore. So the where clause won't work after some time. So then you have to figure out, okay, now I will have 5 databases instead of 1 database. Then each database will be sharded by a hash, and then I will go and get that customer's data from that particular service using my my API tools. So then you'll get into database per tenant. Then you'll get into sharding. So you can evolve it, but at the end of the day, you have to think about these patterns, even if you're not building them on day one. So those are some of the examples on data architecture patterns. And application architecture patterns. So you have, you built a software, you have APIs, you have customers using it and going to your database. And let's say you have a customer key, and everything is good. Now you have 10 more customers coming in. Now you need to be able to scale your containers. Then you would say, oh, let me just scale out my containers, and then we're all good. Now it might work, but then someone will say, I'm a large corporate customer. I need things to be done fast, because it's not everything is about APIs. You have your batch jobs, you have your reports, you have data ingestion, you have your exports going out, you have SFTP. So this is a business corporate type environment, not a consumer oriented just web UI. So then you'll get into okay, now I need to isolate my large customers, heavy loads, small loads. People are only using it for basic subscription or free subscription. Then I need to be able to do something like what I did on the data side, but I need to like request routing to different environments, request routing based on hashing. I need to have like, containers that, a customer comes like, I have to have 24/7, and someone else will say, I'm okay with 15/5. Then you have to have a different type of environment for that. You don't want to spend money, same amount of money on every single type of customer. So then you have to use compute side patterns in terms of separating out these compute workloads so that you can actually make money on any type of customer, large, small, and single customer. So that's where a lot of application architecture patterns come in. And then you have deployment architecture patterns, like, you have what I call tenant feature customer. Like you have features that are only available to some type of customer categories that are paying more money than others. And then you have, some customers that are only using basic or free version. Then you don't want to waste your compute on based on any type of customer. So you have to deploy by feature, you have to deploy by type of tenant, depending on the complexity of the feature and how much expense that is. If you have to use a data warehouse for some type of customers because you are providing analytics, you don't want to provide that to everybody. Like you want to make it like compartmentalized into that particular tenant set or tenant group or a feature group or a customer group, depending on the complexity of that. And then, the other things that are more standard in terms of like Docker supports multi-tenant deployments now. So canary deployments to make sure that if you're rolling out a feature, depending on the complexity of the feature and how much expense that is. If you have an issue, you have instant feedback versus rolling a big feature out to a largest customer. So this is something of an advantage for you versus before, if you are shipping out software, then you have no option to other than just shipping out software or asking people to download. So now you can do that, canary deployments, to different type of customer tenant base to make sure that you can actually get that feature tested and, validated before you roll it out to your biggest customer base. So those are the three kind of categories of application patterns that you should look at. I mean, the SaaS pattern inventory is growing, just the types of problems people are facing and how they're trying to implement. So you should always keep a close eye on. I have some references in the end that you could take a look. And in terms of maturity model, so obviously, if you are building something from scratch, you have a luxury of looking at multi-tenancy from the beginning. But not everybody has that. Like people already build software, they're trying to move that to a SaaS platform. So you might have a varying level of maturity in terms of supporting and scaling customer base. So you might have, just a software that is just single tenant. Everyone needs to have their own, VPC. Everybody needs to have their own, IP address. Maybe you built it like that, and it's just a level 1 of SaaS. Like you could take everything that you currently have, you could also make it SaaS, but it's not. There is no economies of scale in that. But you have to start somewhere. So what I call level 1 is a single tenant platform, but you make it multi-tenancy by deploying it as many times you can, because you are trying to get customers, you're trying to increase revenue, but the software is not ready. So you cannot say, I don't have it. So you have to make it work with a level 1 single tenant model. And there are various different deployment models to support multi-tenancy and SaaS if you are a level 1 maturity of your software. So level 2 is you kind of have some automation, it's already on the cloud. So you could actually create billing accounts based deployments by tagging different software instances that are running either on IaaS or PaaS, and then making it billing code specific. So this way, everything is running in one environment, but you're just creating billing and deployment differently. So it's what I call level 2 multi-tenancy. It's still single tenant software, but you're kind of simulating multi-tenancy. And level 3 is you have a single deployment, you have kind of matured, and then you are isolating compute by categorizing small, medium, large, and different Docker containers, and you have a multi-tenant Docker deployment, or you have your own custom deployment model. Whatever you have, doesn't really matter. But the idea is you have a single deployment model that you could move your software. And level 4, you have full stack. You have isolation on tenant feature customer. You have application isolation, you have, different regions where you are deploying, you have different regulatory concerns that you can address independently from North America versus Europe, like GDPR versus CCPA. So you have regulatory isolation, so what I call level 4. And level 5 is kind of true multi-tenancy, like what I will talk about a little bit more. But, generally speaking, don't try to get to level 5. It's just waste of money. You can try to get there at some point, but it's always a North Star that you'd always like look at, but it's not something that you should practically try. It's just something to tell you that, you could always improve on, but you don't start at level 5. You try to get to level 5, so you'll end up somewhere between 3 and 5 over time. So I'll go through a quick conceptual architecture. So, and then kind of address some of the patterns that we have been discussing. So you have from left to right here, from a corporate consumer, going into your SaaS platform. The first one they would expect to see, just given the type of customers, it is like anybody can join. A lot of countries don't have desktops and iPads, so they might be using mobile for that service. So it has to be responsive. It has to be geo-distributed, so you could use Route 53, Azure DNS, Traffic Manager to be able to route your traffic to appropriate regions, so that you can actually like deliver solutions in that region. If your service is truly global, then that's okay. You don't have to have that kind of like routing, but you could still have that routing for compute needs purposes, like a multi-region deployment, for example. So it has to be geo-distributed. It has to be cloud first, like the examples I talked about, like just given the fact of what SaaS is and the fact that you could always scale, and you would also want to keep the cost more elastic. And unless you have the financing to just build hardware and data centers, that's the only option. You have different identity. So we talked about, so in a SaaS platform, you need to be able to bring your own identity. You cannot just say like, I have a password. You have to create a password on my site, and then that's how you use it. That's fine in some cases, but a lot of the times, like the clients want to bring their own identity. You need to support multiple identity models in addition to having your own identity model. You could use other PaaS platforms as SaaS services to support that. Like Amazon, AWS Cognito is an example, Okta is an example, any OpenID Connect type examples, in addition to providing, them your own, like, way to store authentication information. It has to be support isolation, like we discussed in terms of, you cannot have a single client messing up like the software for some other folks, whether it's intentional, unintentional, whether it's malicious, whatever the case may be. You have to have isolation so the entire application is not down. Or even it could be cloud, like for example, what happened with AWS a couple of weeks ago with Kinesis Streams. So isolation. You have to have different types of compute workloads, forms, business logic, analytics, batch, cloud data services. All of them need to be supporting the same tenant isolation model, not just like APIs. You have data sharding we talked about, event-based queries, where you need to have ability to scale horizontally by tenant, by customer, by feature, by geography, so that you're not putting everything in a vertically stacked environment. If you have a horizontally scalable database platform, you could use that, like DynamoDB, globally distributed databases on Google, like Spanner, but they are expensive software, so you may not want to do it. And isolation at the data level, and then also you need to support all the horizontal services, billing, reporting, analytics, data warehousing. That could be commingled. It's okay. But as long as you have following the various regulatory requirements for it. That's really kind of the summary. I went through it fast because there are a lot of concepts, and I want to take some time for questions as well. And I have some material for you to look at, and how to deconstruct your own application using SaaS Lens. AWS has a lens called SaaS Lens you could use, and then see where you're falling short of your platform to be really SaaS and really multi-tenant. So you could actually have economies of scale. And there are a lot of factory patterns by AWS. Azure has a SaaS platform site. So you could always look at all of these ideas and different tools that AWS and Azure provides, or Alibaba Cloud provides, to see where you need to improve, what is it that you need to build, and if you're building from scratch versus if you're at level 1 and you need to get to level 3 or 4. Okay, so that's all. So I'll take some questions from the team.
Yeah, so hi guys, this is Anjani. So you can directly, those who are on the stream who are live, they can chat. They can send the chat, and I will pass that to Suresh. And obviously the question hour is open, so yeah, would invite questions, please. So
Yeah.
Kamal has a question there. Yeah.
Yeah, sorry. While we're looking at that, I just wanted to quickly, before I go and walk you through how to claim your certificate, I had a quick question. It was fantastic. It was really clearing, and especially the way you were merging. So you did mention that about the RDS from AWS. Even if we are taking as a package there, you wouldn't call it as a SaaS. Can you just give me a little more on that? Because what my understanding was, so I did work on AWS and Azure, both side of it. But whenever we talk about the Azure data warehouse with the whole BI platform along with it, like a modern data architecture with the Azure or the AWS, it does says that it's a SaaS platform. So that basically a little confused me.
Yeah. So it's actually depends on. So as I said, it depends on your point of view. But for me, like the main things are these. Like, is it doing all these? RDS doesn't solve a business problem for me. But yes, it is a platform as a service. For me, it's a PaaS solution. So it's not a SaaS solution. Because it's not doing these, like doesn't tell me anything about compartmental. It's only vertically scaled platform. It doesn't solve any uneven demands. It doesn't solve a business problem. It doesn't do any tiering of services. You could say like, oh, I could do like add more memory, add more compute, add more caching, like, you could call it service, but it's really like core thing is it's solving the business problem. Otherwise it's a PaaS.
I see. Yeah, I see where you're going. Yeah.
But you could debate, like we can spend our mind and debate on that. But
yeah, I agree. Absolutely. Thank you so much.
Yeah. So there are a couple of questions on the chat. So the one question is from Kamal, who says, from a data localization point of view, if my SaaS is applicable across globe, does it need to be hosted in different areas like in US, Europe, and India?
Kamal, so like without knowing the details of your thing, I would say. It has to, just given a lot of the privacy regulations these days that are coming up. If you are pitching to an European organization, you have to be GDPR compliant. And if you are taking in customer information from Europe, anywhere in Europe, you have to be GDPR compliant. And if you are doing something in California, you have to be CCPA compliant. So it depends on what you're trying to do. If you're trying to do something like a casual consumer-oriented application, it's not even considered a SaaS platform. So, but generally speaking, like, absolutely. Like, if you have to be, strict with the laws, if you are trying to collect data from California, and if you are trying to, gain revenue from California, you have to be CCPA compliant. And same thing with Singapore, same thing with Europe. Like, so unless you're trying to build a casual solution, and you could always like have the customer sign off all the waivers, and then you could do whatever you want. But that depends on what the solution is that you're building. But answer is yes.
The next question is, I am in the mid of development, through SaaS platform in Kubernetes. Any recommendation on the multi-tenant architecture for the Kubernetes multi-tenant?
Yeah, so Docker has something new in Docker Enterprise. It's called Docker multi-tenant deployments. So you should definitely take a look at it. Kubernetes is just an orchestration on top. But, you could also have, once the containers are made specific to tenant, then you could actually orchestrate through Kubernetes in terms of which tenant groups by tags that you want to shut down, scale up. So it's really more at the Docker level, but you could also use the tags on Kubernetes to actually run commands to scale up and down different features.
Does that answer your question, Satish? You guys can mute and talk. Yeah. So.
Yes and no, Dheeraj. So
this is Anjani. Yeah. I think you can talk to Suresh directly. This is Anjani. Yeah.
Hey, hi Suresh. So is the only isolation on the Docker multi-tenant, will it work? Because I'm developing a product for a big banking customer across the Europe. and every tenant has to be completely isolated from the data, from the compute, and from the everything.
Yep.
So there are a
Full
lot
stack
of
isolation. Yeah.
and I'm not getting a right approach or the right, I would say, the style of architecture. Everybody talks a lot, but I'm not getting that right direction. So I'm just trying to get some inputs.
Yeah, sure. So, in terms of, first of all, if you're working for a large bank, there's a lot of other constraints you have to deal with before you get to this topic. But in terms of specifically your question on, data isolation, it's really geographical based deployment. And, that's the simplest answer with a lot of banks. In terms of middle tier, where your, containers like compute workload needs to be isolated. So there are two things. One is you could have your stateless containers. You could have like your stateful batch jobs like that running like, hours and hours of work. So both of them, you could deploy them as part of your container jobs. But if you have to isolate them, you could isolate them on a single VM. If your large bank has, OpenShift or some other deployment models, then you could isolate them by container. But even within a single VM, they are still isolated, meaning there is no sharing of memory. Docker isolates it. In terms of data, it's a completely different question. And in terms of downtime, it's isolated by tenant, and then you could assign compute resources by Docker container or by tags, so that compute is also distributed equally. But in large banks, it's a complex answer, and then you have to look at a lot of different variables. But data side is easy. Like you have to isolate because of regulatory. You just isolate the data, as long as there is no cross connect. So if there is cross connect, like someone in North America is sending data to Europe, and then you need the data to be only available in Europe, like then you have to do some complex cross-cutting concerns. But generally speaking, different deployments for database, and then corresponding containers will have their own resources that, like, let's say you're writing Spring Boot or something else, they will go to their corresponding data sources because that is deployed per tenant, and then it has its own configuration files. So there is no cross between different containers. So, but there is no like single answer. So you have to look at your deployment model. You have to look at what is the constraint in the bank, and then what are some of the things that they have to do to support it. But from a Kubernetes and Docker point of view, that's one of the main reasons why you could do multi-tenancy, because of containers. Otherwise, it would have been a lot harder to do it, even if you have VMs.
I'm also using OpenShift, but I'm looking at the larger Kubernetes community, but they are saying isolation just with the namespace and RBAC. But I'm looking still more than that, because that namespace and RBAC isolation is just a basic part of Kubernetes. So I'm just looking for some other recommendation. I'm doing in the middle of research, so that I'm getting a lot of other inputs as well.
So it's basically like, you have a tiering of Kubernetes clusters. I forgot the term that you use. Like you could actually have a master Kubernetes orchestrator that is managing the mini Kubernetes clusters, which has its own container pool. So let's say if you have like 10 customers, 10 of them have like 5 different containers that are doing different kind of things, and then you have to orchestrate at the master Kubernetes level. Then that's what you have to do. I think it's called cube of cube. I forgot the term that is used. I'm not like, even though I'm certified in Kubernetes, I'm not like specialist. I don't do this every day, but you could actually have a cluster of Kubernetes clusters.
Sure, Suresh. Thanks for your inputs. I will definitely look.
Yeah.
Then another question is, Suresh, it is like a CRM focusing on service contracts. This is from Kamal.
Yeah, Suresh, Kamal here. You have answered the first question, right? So my product is either service contract with B2B. So the problem which I'm getting is that I have a few customers lined up in US, and they sign up digital contracts with their customers who are in Europe. So basically, the customer exchange is happening between US and Europe. In this situation, how do I manage the data localization between these two countries? It is B2B, it is not consumer oriented.
So B2B, then you don't have to worry about a lot of consumer privacy laws. But if you're doing B2B, then it's actually regulatory ones. I don't know if you have any regulatory requirements on this. Like, I don't know the space on what kind of contracts it is. But if it is regulatory space, then, the requirement in Europe is depending on the regulation, the data cannot leave Europe and it could stay in Singapore. So either you put the data in Europe or you put the data in Singapore. And for US, the data needs to be in US or it cannot be in Asia. So, so you have to put it like Canada or someplace else. So it depends on the regulation. So I can't really answer that particular question without knowing the actual regulation that you have. But we have I've worked on some examples where the data cannot be in US, cannot be in Europe. Then we put it in Canada. The data cannot be, the European data cannot be in US, so we put it in Singapore. So I don't know the answer to your particular question.
Okay, thank you. It is something like a DocuSign API. We invoke DocuSign API for digital contracts.
Yeah. Okay, so then but DocuSign has its own thing. You can't really control where DocuSign is storing if you are a small customer. But you can store your data, meaning the metadata that you use for contracts, someplace else, and that could be in Canada, that could be in Singapore, depending on who owns the data, between your customers.
Okay, thank you.
Yeah.
There's another question from Deepak Singh. How is CG group based isolation in container helpful in the process of creating isolation? So he says, how is C group based isolation in containers helpful in the process of creating isolation?
I don't know the answer to the question. I don't know.
Okay. Any other question, team? Or
All right. I think let me quickly walk you all through how to claim your certificate. I just shared the code of the certificate, which is capital SAA. S as in Sam, A as in America, A as in America, Sam, Kevin.
So it's
it's
a short form is SAS Suresh Kandula.
That's correct. So SAS KSK. What I'm going to do, I'm going to quickly share my screen and show you how to claim that. Let me know when you see my screen, Anjani. Can you?
Yeah, I'm giving another easy option to claim it. So just give me a moment. Because I'm pinging you the URL. So here you go. That's the link I've pinged you. You can see. Are you able to see?
Okay. Yes.
Yeah. People have just to click this out. If you can.
So let me just share my screen and show you what has to happen. I will go back to the chat window.
Yeah, that's the URL. Yeah. Just go there.
So the moment you click in this, all you got to do is to put your name, your number, email ID, click on accept the terms and condition, click next, put the code, which is SAASSK, all in caps again. Go to next, hit submit. And that's it. So now so there are two ways you can get the email, or you can go back to the fifth IR to claim your own certificate, which I'll just quickly walk you through. Say that again. Sorry. Go ahead, Anjani.
No, it's okay. So you just go on Fifth AI, log in to the community or anywhere. Go to any course, and then once you are there on your screen, actually you will get an email. It may go into a spam. You will have to see. And then you will have your account area from where you can see this. So if you try login, Dheeraj,
Yep.
go to anywhere, Just go to any course. Go inside any course. Events, yeah. Just click anything, yeah. Okay. And then just select go next. It's the same page, but it acts differently. And then once you are here, the session is happening here also. Scroll down. Scroll down, you can see the live streaming is happening here. Scroll down, Dheeraj. Yeah, so and go up and you can download the certificate from here. Or at the top, you can go into the account section. Account and then my certificates. So you will see once you click that out.
That's correct.
Yeah. So you'll be able to see your certificate. You can download, you can share it. This is LinkedIn attachable. You can directly attach it to LinkedIn.
That's correct.
Sanjani, that's really great. Is Suresh, are you still there?
Yes.
I'm here.
Hi, Suresh. Just wanted to say, absolutely great slides. Really cleared up a lot of information for me. You've presented in a number of slides, so it's really informative. Thank you for that. Just one question from myself, if I may. One area I find a little bit difficult to distinguish between is DBaaS and SaaS. And I was wondering, do you regard DBaaS as basically its type of SaaS? Or how would you distinguish the two?
So, first of all, I don't consider DBaaS as SaaS because that's probably why they didn't want to call it SaaS. It's for me, it's SaaS, and also generally in SaaS, like if you look at like the top SaaS companies, they're all solving a business problem. DB as a service is not solving a business problem. It is solving a platform problem. It is a fully managed service. It is solving a problem. It is not solving a business problem, and it is not a self-service.
I think that's
That's
great.
why I don't call it SaaS.
You know, that's a very direct answer. You've hit it straight on the nail. Thank you very much indeed.
Sure. Yeah, but I would generally like not spend too much time sweating about whether it's SaaS or not. Like just get into the details. But it's really the patterns that are more important. If you run into the challenges of any one of those challenges that I mentioned, But yeah, there are many different points of view on what is SaaS, what is PaaS.
Okay.
I agree. Yeah, that's correct. Cool. Thank you all. It was fantastic. Thank you so much, Suresh, personally. And thanks all. Good night to the people who are there in India and other places, and have a nice day to the people who are in US and wherever we have the daytime. Thank you all.
Thank you, everybody.
Thanks, everyone.
Thank you.
Thank you. Thank you. Thank you very much.
Bye.